Have you ever wondered what our Earth is made of? It's a question that has piqued the curiosity of scientists, scholars, and stargazers for centuries. Just as we are composed of cells, bones, and organs, our home planet too is made up of intricate layers, each with its unique role to play in the grand scheme of things. Our journey begins with the thin layer we walk on every day, the crust. Beneath it lies the mantle, a hot, viscous layer responsible for the continent's drift. Deeper still, we find the outer core, a liquid layer of iron and nickel, and at the very center of our planet lies the solid, incredibly hot inner core. Understanding the composition of the Earth is not just about satisfying human curiosity. It holds the key to understanding the planet's past and predicting its future. So, buckle up as we journey to the center of our planet. First, we step on the Earth's crust, the part we live on. It's easy to take for granted, isn't it? But there's more to it than meets the eye. The Earth's crust is, in fact, the outermost shell of our planet. It's the skin of the Earth, so to speak, and it's made up of an incredibly diverse collection of rocks and minerals. Now, the Earth's crust isn't a one-size-fits-all kind of deal. It actually comes in two distinct types, the oceanic crust and the continental crust. The oceanic crust, as you might guess, forms the bottom of our oceans. It's thinner than its continental counterpart, averaging about 5 miles in thickness, and is primarily composed of dense rocks like basalt. On the other hand, the continental crust forms the continents and the areas of shallow seabed close to their shores, known as continental shelves. Unlike the oceanic crust, the continental crust is much thicker, ranging from about 19 to 31 miles, and it's composed of less dense rocks like granite. The composition of the Earth's crust is quite fascinating. It's primarily made up of 8 elements. Oxygen is the most abundant, followed by silicon. The other 6 elements, aluminum, iron, calcium, sodium, potassium, and magnesium, all play their part too. These elements combine in various ways to form the minerals that make up the rocks of the crust. And it's this crust that plays host to all life as we know it. It's where we build our homes, grow our food, and extract the resources we need to survive and thrive. It's also the site of majestic mountains, expansive plains, and deep valleys that make our planet not just habitable, but beautiful. While it may seem insignificant, the crust is our home, and it plays a crucial role in our survival. Deeper than the crust, we find the mantle, making up a whopping 84% of Earth's volume. Yes, that's right, 84%. It's a layer so vast it dwarfs all other layers of our planet. But what exactly is the mantle? And why is it so crucial to our planet's functionality? Picture this, a hot, flowing layer of rock. It's not molten, but it's not solid either. It's somewhere in between, in a state known as plastic or semi-fluid. This is the mantle, and it's a world of extreme temperatures and pressures. In fact, the deeper we go into the mantle, the hotter and more pressurized it becomes. It's a fiery world of rock, constantly in motion, flowing and twisting like a river of stone. The mantle isn't just one uniform layer, though. It's divided into the upper and lower mantle. Each layer has its own unique characteristics, thanks to the different temperatures and pressures they experience. The upper mantle, for example, is cooler and more rigid, while the lower mantle is hotter and more fluid. Now, you may be wondering, what is the mantle made of? Well, it's composed mainly of silicate rocks. These are rocks rich in silicon and oxygen, but they also contain other elements like magnesium, iron, aluminum, and calcium. These elements combine to form minerals that make up the bulk of the mantle. The mantle plays a crucial role in shaping our planet. It's the engine room of Earth's tectonic activity. As the mantle flows and shifts, it drives the movement of the Earth's crust, causing earthquakes, volcanic eruptions, and the creation of mountain ranges. In conclusion, the mantle is more than just a layer of hot, flowing rock. It's a dynamic, ever-changing world that powers the very life of our planet. It's where the energy of Earth is generated and transferred, shaping our world in ways we often take for granted. The mantle, with its intense temperatures and pressures, is a driving force behind Earth's dynamic nature. Next, we plunge into the outer core, a sea of molten metal. This is a realm of extremes, a turbulent ocean of hot, liquid metal that churns beneath our feet. It's a world apart from the solid rock of the mantle above and the iron heart of the inner core below. This is the outer core, the middle child of Earth's layers, and it plays a crucial role in shaping our planet. Composed primarily of iron and nickel, the outer core is a liquid layer that spans a mind-boggling radius of about 2,200 kilometers. That's more than 5 times the length of the Grand Canyon. This layer is incredibly hot, with temperatures soaring between 4,000 and 5,000 degrees Celsius. That's hotter than the surface of the sun. But what makes the outer core so important? Well, it's all about magnetism. The outer core is responsible for creating Earth's magnetic field, a protective shield that guards our planet against harmful solar radiation. Let's take a moment to understand how this works. As the Earth rotates, the molten metal within the outer core moves, creating electric currents. These currents generate a magnetic field that extends far into space. This magnetic field is what makes a compass needle point north, but its most important job is to protect our planet. Without this magnetic field, solar particles would strip away our ozone layer, the shield that protects us from harmful ultraviolet radiation. Without the ozone layer, life on the surface would be exposed to intense solar radiation. This could lead to increased rates of skin cancer in humans and harm to plant life, affecting our food chain and ecosystems. So, while the outer core might not be the most glamorous layer of our planet, it's certainly one of the most crucial. It's the unsung hero of Earth's structure, quietly protecting us from the dangers of space. Without the outer core and its magnetic field, life as we know it would cease to exist. So, next time you use a compass or enjoy a sunny day, spare a thought for the molten sea of metal beneath your feet. Finally, we reach Earth's heart, the inner core. As we delve deeper into the core of our planet, we encounter a solid ball of metal, a place where the conditions are as extreme as they get. It's here that things become quite fascinating. This solid ball is predominantly composed of two elements, iron and nickel. Yes, the very same metals that you might find in your everyday cutlery or coins. But don't be fooled by its familiarity. In the inner core, these metals exist under conditions that are anything but ordinary. Imagine the weight of all the rock, all the oceans, and all the life that resides above it. The pressure here is unimaginable. It's roughly 3 million times the atmospheric pressure at sea level. That's as if every square inch had the weight of 3,000 cars pressing down on it. Now that's a lot of pressure. But the extremes don't stop at pressure. The inner core is also incredibly hot. We're talking about temperatures that exceed those on the surface of the sun. Yes, you heard that right. The heart of our own planet is hotter than the surface of the sun. It's estimated that the temperature ranges from 5,000 to 9,000 degrees Fahrenheit. That's enough to melt any metal on the surface of the Earth, but not in the inner core. The immense pressure keeps these metals in a solid state. Despite our best efforts to study it, the inner core remains shrouded in mystery. We've never been able to reach it, and we probably never will. All our knowledge about it comes from studying seismic waves that pass through the Earth after earthquakes. But even with these limitations, we continue to learn more about this enigmatic part of our planet. The inner core, under unfathomable conditions, remains one of the most mysterious parts of our planet. So the next time you look down at the ground beneath your feet, remember, there's a whole world of wonder and mystery lying miles beneath us. From the crust to the core, Earth is a complex and beautifully layered marvel. We've journeyed through the layers of our planet, starting with the crust, the thin shell that hosts all life as we know it. We delved deeper into the mantle, a vast, hot, and slow-moving sea of rock, playing a vital role in driving the planet's tectonic activity. We then ventured into the outer core, the source of Earth's magnetic field, a protective barrier shielding us from harmful solar radiation. Finally, we arrived at the inner core, a solid iron-nickel sphere amidst intense heat and pressure, the heartbeat of our planet. Each layer, each component is essential, intricately connected, and contributes to the dynamic and vibrant world we inhabit. It's a testament to the intricate design of nature and the ongoing evolution of our planet. So next time you step outside, remember, beneath your feet is a world of wonder, just waiting to be explored.